Whether you're developing coatings, inks or cosmetics in a laboratory, or testing during the production process, measuring the particle size of the material, also known as dispersion, is an essential part of ensuring reliable and repeatable formulations. Typically, to measure dispersion, fineness of grind gauges are used. Elcometer's fineness of grind gauges consist of a stainless steel block with a precision ground scraper. Each block has either one or two channels, precision ground in a uniformly increasing depth from 0 at one end to a specified depth at the other, identified by the scale on the gauge. Elcometer precision manufacture and supply 3 different types of fineness of grind gauges. Dual channel gauges, such as the Elcometer 2020, which are available in various scale ranges and are ideal for testing the dispersion of many materials, including paints, coatings, cosmetics, chocolates and other similar products. The Elcometer 2020 gauges are available with either mil or micron scales, and include 2 other scales as standard, the PCU or North scale, where your material is compared with a known sample, and the NS or Hegman scale, which reports the distance from the deepest end of the channel. Dual channel gauges also allow you to test different material formulations side by side, so you can instantly compare the results. Alternatively, there are high precision single channel grindometers, such as the Elcometer 2050, available in either mils or microns. The combination of the same depth that's precision ground across a longer channel means the Elcometer 2050 allows you to measure to a greater accuracy of plus or minus 1 micron or 0.04 of a mil. And the MPIRI fineness of grind gauge, the Elcometer 2070, precision made for determining dispersion in printing inks according to the National Printing Inks Research Institute scale, as well as either mils or microns. Before you start, ensure the surface of the gauge and the scraper are clean from previous test materials, dust or oil, and ensure the surfaces are not damaged, as dents and scratches will affect the accuracy of the result. Place the gauge on a flat, horizontal and non-slip surface, with the 0 mark on the scale closest to you. Then, place a suitable amount of the material you're testing in the deep end of the channel or channels. You should slightly overfill the channels to ensure you have enough of a sample. Holding the scraper in both hands, place it behind the material. Depending on the test method or standard you're working to, you should hold the scraper either perpendicularly to the surface of the gauge, or with the scraper slightly angled towards you. Now, pull the scraper along the length of the gauge at a constant speed, applying downward pressure as you do to push any excess material to the edges of the gauge. Stop the pull at a point beyond the 0 depth on the gauge, ensuring your sample has been scraped over the entire length of the channel or channels. You could even place a sacrificial piece of paper or cover at the end of the gauge and scrape the excess material straight onto it, making it easier to clean later. This whole action should take around 1 to 2 seconds in total. Within seconds of completing the pull, turn the gauge sideways so it's perpendicular to you and view the surface of the material at a 20 to 30 degree angle to read the result. If you're using the Elcometer 2020 or Elcometer 2050, look at the deep end of the gauge and move to the 0, and find a band across the channel or channels that's 3mm or 1/8 of an inch wide, which contains 5 to 10 particles of the material. Once located, read the position of the upper limit of this band on the scale and record the value. When using a dual channel gauge, you should read each channel as an individual result. Alternatively, if you're using the Elcometer 2070 NPIRI gauge for printing inks, then once again